Okay, welcome back for another tutorial. In this lesson, we are going to be going through Lathe Lesson 7 exercise, and basically this is following a tutorial. So this is the exercise to the tutorial of Lathe Lesson 7, the handout. And actually, let me bring it back over real quick. As you can see, this is very similar to the tutorial, very similar. I mean, they shifted this, made it a little bit, shifted it over a little bit. They changed this angle a little bit. It's extremely similar. So everybody really should be able to do this without an issue because the tutorial walked you through this almost perfectly. So let's go ahead and get started. The last time, well, first off, let's select our machine. Start off by doing that. I'm going to select my 4-axis Haas lathe. Again, you can select default if you like. As long as it has the ability to do everything that is required, that is fine. I don't really care what post you select. Okay, so we got that selected, and let's go ahead and change our plane to DZ plane equals. All right, back to toolpaths. Okay. All right, so we're all set up. So now I'm going to start drawing my part. Last time I drew this where I just started with the profile, the outside profile, and then I added the counter bore later. I'm going to say chamfer there. I added the counter bore later. I'm going to start with the counter bore this time. So we're going to start at a 0, negative 0.125, and we're going to go to 0.5, negative 0.125, and then we're going to go to 0.5, 0, and then we are going to go to 0.875, 0, 0.875, negative 0.25. And then we're going into a groove there, which is 100 thousandths deep. So to get that diameter, we have to take 100 thousandths off both sides. So it's going to be 200 thousandths. We're going to subtract from the 875. So we get 675 the diameter. So we're going to go to 0.675, negative 0.25. And then we're going to go to 0.675, negative point. Looks like this case it's 200 wide, so we're going to go to 0.45. Enter. Okay, and then the next one that we have there is going to back up to 875. So 0.875, negative 0.45. Followed by, okay, so here we're meeting a radius. So I'm just going to draw a straight line here. And like we did in the tutorial, we're just going to go ahead and connect this. One thing I do want to check is this kind of looks, steel kind of looks a little bit funny, like it's crushed in. I think that is just my resolution. I have a big screen here that I'm working on. And as you can see, that is correct. So that's good. It's good that it shows it correct. It just looks a little like it's smashed, but that is actually right. All right, so let's go ahead and let's start at the top of this angle like we did in the past because we have both dimensions for that. So let's go ahead and go to our wireframe endpoint again, line endpoint. We're at 1.125, and we are at a negative, well, let's just do this. So as mentioned in previous lessons, you can actually put an equation in here. So we can do a negative shift 3.1 minus 2.0. Now that's an easy equation for us to do, but just wanted to make the example, obviously, that you can put that in there. Okay, so then we just need an angle. So right here, this is a 45-degree angle. So we know that this is obviously going to be 45. It's going to be negative 45 from the 3 o'clock, or 3 o'clock. So we're just going to put a negative 45. I'm going to lock that in and hit check. And I'm just going to draw that line. And then I can trim them. So I can come back, and usually I do this afterwards, but I'm just going to do it so you can have the visual right now. Okay, so now we have this, and then we can add that radius in there later. It looks like we have a radius. Let's go ahead and start from the back and meet up with this, because I think that's probably the easiest way. I could draw the straight line here. Actually, I'm going to draw that first. I'm just going to draw a straight line that I know is longer than I need. It might not actually be longer than I need. Let me make that a little longer, just for the heck of it. You can always trim it at the end of the day. Okay. Okay, so let's go ahead and start from the back now. 1.375, comma, negative 3.1, enter. And that is going to 1.375, comma. Looks like that is an 1/8 inch wide. So that's going to be negative 2.95. Enter. And then we're going into a groove, which appears to be 200 thousandths deep. So we're going to have to subtract 400 thousandths from our 1 inch, which means we are going to be at 0.975. So we're going to be at 0.975, comma, and we're still at negative 2.95. Enter. All right. Then we are going to 0.975, comma, and it looks like that's 200 thousandths wide. So we're subtracting 325 thousandths from 3 inches. So let's go ahead and put a negative in, and let's go 3.1 minus 0.325. Enter. And hit enter. And there is our correct point. So if you have trouble with any of the math, you can always just put it in that equation. And then once you have it, we can actually see where we're at down here based on our z. So you can see our z is at 2.775. So now you can type that in now that you know where that's at. We are going back up to 1.25, comma, negative 2.775. So you don't have to type in that equation each time because you can basically see where you're at down there. Okay, and then it looks like this is going over. All right, so what we're going to do is I'm just going to draw a line there, and we're going to make that angle in there. Okay, so let's go ahead and create our line again. That's going to start at 1.25, comma, and it's going to be, looks like it's 625, 3.1, so it's going to be negative, and it is 3.1 minus 0.65, enter. Looks like I just didn't quite go far enough. That's all right, we can extend that. I'll show you how to extend that and get that to connect. Okay, so it looks like we are 160 degrees. Looks like it's 160 degrees. And what we have to figure out is what angle would that be from a negative perspective. So what we'll do is we'll take 180 and we'll subtract 160, which gives us 20 degrees. So that would be a negative 20 degree. So we'll go ahead and put in negative 20 point, and that locks us in at 20, and there is our angle. So we can, well, actually, let's wait to do that. Let's do a modify length. We're going to lengthen it by 0.1. I'm just going to hit this, and there we go. So I just lengthened that a little bit so I can trim it, and there we go. So there is our basic profile. We still got to add, of course, this radius of 0.3 in. Let's go ahead and do that now. So it looks like the center of, okay, so it's calling out 450 thousandths lower. So the bottom of that radius, let me pull this over so you can see it. So it's calling the bottom of this radius out from this here diameter. If I zoom out here, it looks like that diameter is 1.25 inches. So if we take, oh, sorry, it's 450 from center. I apologize, 450 from center. Okay, so it's 450 from center line. Then we have a 900 diameter here. What we need to do is add 600 because we got to multiply this times 2, right? Because it's 450 from here to here, and it's another 300 from here to here. So if we take the radius, so from center to here, 450, plus another 300, we get 750. 750 times 2 is 1.5. So we have a 1.5 diameter. That is where the center of our circle is, at 1.5 diameter. Okay, and then of course it is 1.25 from the back side. So we'll do an equation for that one. All right, so we're going to go put our center of circle at 1.5 diameter, comma, negative, and I'm just going to say 3.1 minus 1.25, and hit enter. And there's our circle. Okay, so if a circle looks a little bit of an ellipse, that's just because of my screen resolution. I assure you that it is not an ellipse. Let's put our radius in, 0.3, enter, and there we go. And now we can trim that. So we'll just divide, oops, undo. If that happens to you, you can just hit undo. And what you have to do sometimes is zoom in on these things just to get it to select. It's really weird. I'm not sure why it does that. Okay, so there we go. Now I know this doesn't look exactly like our print. Again, that is just because of my screen resolution. I assure you it is to size. You saw the dimensions that we put in and they were all correct. Okay, so we have basically our profile. We just need to add chamfer and I believe a radius here. So let's go ahead and do that. Let's add a fillet and we're going to put in a 0.6. Oh, sorry, 0.05, I think, right? Yeah, 0.05. 0.05 fillet. And that goes right here. Check. And we're going to add a chamfer, which is up here. And it looks like we have a 62 thousandths, 0.0625. Put a 16th chamfer on the front. And that looks good as well. All right. So there is our profile. That is our finished profile. All right, let's go ahead and get started with machining this thing. All right, so the first thing, of course, I'm going to do is open up my properties, go to my stock, and I'm going to, of course, change my stock plane to DZ, and I'm going to change my stock. Looks like we need 3.1 for our length, 3.1. Our OD, our max OD is 1.375. Let's make that 1.5. Let's say that's what stock we have. You should never, even for these tutorials, you should never use an exact stock size. So if 1.375 is actually a common stock size, or fairly common, but if if the outside of the part is 1.15, you should not use 1.15 because that is not a realistic stock size. Probably not going to see that stock size or be able to buy that readily. Not to say that it can't be bought, but it's probably a custom mill run. So you would only have something like that if you were making millions of parts. So in this case, we're going to use 1.5 because that's a more realistic size probably to have on our shelf at the college. All right, we're going to use the margins, and I'm going to put 0.1 in. Actually 0.01 in the margin. Left margin, we're going to hold on to 2.0 for the into the chuck, so I'm just going to add that for visual effect. Check, and check, and we are good to go. All right. Again, you don't have to put your jaws on. I don't usually put them on, so you don't have to either. By the way, if you're wondering why these are a different color, it's just because I have my colors different on this machine. I haven't really set them up fully yet, so I'll have to take care of that and change that here at some point. All right, so we are ready to machine. So let's go ahead and add some tool paths. Let's face this thing first. Of course, we're going to use our 80-degree diamond. Our max spindle speed is 3,000. As you can see, I did not set up some of these tools, so we have different speeds and feeds. 900 will be our constant surface speed because that is generally what our Kennametal inserts run at. We'll face at 0.006. And let's take a look at the face parameters. Everything in here looks good to me. I don't see anything that is of issue. I don't need to change my cutter compensation because, of course, I'm only facing in the x-axis. If I'm using both axes at the same time, that's when compensation is critical. So I'm going to go ahead and hit check, and you can see there we have our face pass. All right, next, I know that your book had you use the quick rough and quick finish on the tutorial. I really don't use those very much just because they don't have as much flexibility. So I choose to use either the rough or my canned rough. In this case, we're still going to use the rough. I'm going to go through the canned rough in a future video. Okay, so we're going to use a partial. Come in, select this, select the end, hit check. Oops, forgot to set my speeds and feeds. 3,000 max, 900 constant surface speed, 10 is good. And let's go ahead and turn on our stock for outer boundary. Depth of cut 0.1 is good. Minimum depth, let's make that 0.005. Basically what that minimum cut means is that if it starts doing the roughing, and let's say our finished diameter is 0.799, if our finished diameter is 0.799 and it does the roughing and it roughs it down at 100 thousandths per pass, it's going to leave a thousandth on for that minimum cut. Of course, that's not including the finish pass and all that stuff. I don't want it cutting just at that. All that's doing is burnishing it. In fact, I usually even make this bigger. I usually make this like 0.02. That way it takes at least a decent cut. These cutters, especially these roughing tools, are designed to cut a little bit deeper cut. They're not designed to cut, a thousandth off at a time. So you really shouldn't have that at 1,000. Stock to leave in the X, we're going to leave that at 10 thousandths. To leave in the Z, we're going to make that 5 thousandths. All this entry amount stuff is all fine. We're going to put on our control. Actually, I'm going to leave it on computer for now so we can simulate it and it looks good. This changes the way that it looks because it doesn't show the cutter compensation on. We're off to the right. That's good. Lead in, lead out. So our lead in looks good. That means it's just going to lead straight in this direction. I don't need to extend that contour. Our lead out, I am going to extend that. Our lead out looks good. That's coming back out away. I'm going to extend this 0.15 because I want enough room for my cutoff tool. All right, everything else there looks good. We do not need to plunge. We're going to take care of this a different way. So we're not going to plunge anything, and we're going to hit check. And that looks good. So there is our roughed pass. Okay, so now let's go ahead and put a finish pass in. I'm just going to hit last for this. It selects the last path that I used. Moving forward, here we go. OD finish. So we're going to use this 35-degree diamond. Again, we're going to max out at 3,000, and I'm going to max this out at 900. Feed rate's 5. That's good. It's going to leave us a good finish. I could go a little faster than that if I wanted to. But I'm just going to leave it at that. We're going to leave nothing on. I'm going to leave computer on for now, and I'll go back and change these after we simulate it. Lead in, lead out. It's important, before I go on there, it's important that you remember to come back and change this because obviously that's going to give you dimensional issues. So if you run a part and it's not quite coming out right, go back, make sure that this isn't the culprit. Okay, lead in, lead out. Of course, I need to change that. This is lead in, that's good again. You can see the lead outs are good. I just need to extend this to 0.15, hit check, and we're good to go. Okay, so that runs our finish pass. That looks good. Okay, so now that we've got our finish pass in there, we're gonna go ahead and take care of this groove. And I'm gonna do this a little different than we did in the tutorial. I'm actually gonna take 2 finish passes on this because I'm gonna do a 10 thousandths finish pass rather than just splitting it evenly like I did in the last one. Okay, so let's go ahead and go to our turning and let's go to finish. And I'm gonna select single and select that path. Now, actually, real quick, no, I don't want to keep that. Let me just talk about one thing here. So one of the things we have to worry about here is tool clearance, whether the tool can clear that or not. So if I go back and select that, hit check, and I select my tool, you can see that this tool has a lot of clearance. Now, I don't know if that's going to select right now. I don't know if that's going to be clear of, basically gouging into this back corner here or not. That's something that you have to figure out when you're programming by hand, and it's very difficult. Fortunately, in this software, it's very easy to see here and very easy to spot if that is the case. So we're going to go ahead and pick this tool. This is an ideal tool, but worst case scenario, there's some other tools that we can pick if this is a problem. So let's start with this one and see how things go. So I'm going to pick 300. Speeds 3,000. Speeds 900. 5 for finish. Yeah, that's okay for this. We could probably actually make that 8 because we're going to be roughing it. This is actually going to be a finish pass that's used as a roughing pass. Go ahead and hit finish. We're going to go 2, and I'm going to say step over 0.5, and we're going to leave 0.005 and 0.005 in the Z. Okay, we're going to leave it on computer compensation, of course, so we can see it simulate correctly. Lead in, lead out, we want to make sure that, number 1, we extend our contours. So we're going to make this 0.05. Otherwise, we're going to kind of plunge into the stock here. So we want to start a little bit up, kind of extend this past a little bit. Our lead in looks a little goofy because see how we're leading in straight? Well, we don't want to lead in straight for this, do we? That doesn't really make a whole heck of a lot of sense. So I really think we should probably lead straight in like this. So we should come from up here and come straight down. Leading in like this doesn't make any sense to me. Okay, so let's go ahead. This lead out would be okay because again, now we're on the opposite side over here, and we'd be leading out that way. So that's okay. Extend. So we're going to extend this 0.05 and hit check. And then just to really show you what I mean there, so it would lead out like that. And that's fine over there. The reason we're not leading in this, like coming from here and leading into this arc, is just because that would be using the back side of the tool, and we don't really want to do that. So if we come straight down, that'll be just fine. Plunge primers, we need to turn those on. So we go ahead and hit check, and check, and check. Okay. So you can see here that we have a bit of an issue. See how it's basically grooving? It's not knocking that, it's not cutting that corner. That is a direct result of this thing not having enough clearance, that tool not having enough clearance on the back side. So let's go ahead and go back in there and let's select a different tool. First off, let me do one other change here. I have 0.5 for the step over. That's definitely a problem. I want 0.05. I noticed that by the path that it's making up there. There we go. Check, and let's regen that. There. That looks a little bit more normal. So there we go. Now let's go in and change that tool. So we have some options here that we can use. One of them is this button tool. This thing is probably the most versatile. The other one is going to be, and we don't have it in this, let's see if we can find it in a different library. What we'd want is a straight. It would come straight down, and it would be a 35-degree diamond. Let's see if we can find it in, maybe in Kennemental Lathe Tooling Inch. Nope, nothing in there. Let's see what the filter has on. Yeah. All right, well, we can use the, oh, here's something. ISCAR might have something in here. Nope, I don't have one either. Well, no worries. Basically what we can do is we just go to Lathe Inch. We can just use this button tool. This button tool is extremely versatile. One of the problems with the button tool is generally turning OD button already exists in the list. Okay, yeah, it's fine. So the radius on this is 0.187. The one thing that we want to make sure of is that that radius fits easily within our radius, and of course it does, right? So we don't have to worry about that. So I'm going to select this tool, and everything pretty much stays the same. So let's give that a try and see what happens there. All right, so there we go. You can see there it cuts it. Now this is showing the center of the tool, so that's why you see the line so far up here. You have to think that the center point of that insert is right about here, and then the radius of the tool is way out here, so it's cutting away. Just remember that this line doesn't show where it's cutting. Where it's cutting is shown by this dotted line, this gray dotted line. So it looks good. Looks really good. We have our 10 or our 5 thousandths left on, as you can see. And now we can come back in and we can run another finish, hit last, check. Same tool, same everything here. We're going to run 1 this time. Step over doesn't matter. We're going to make this 0. Take everything off. All of our lead-ins should, oh, nope, it doesn't carry those over. So we're going to extend those 0.05, and our lead out, we need to extend 0.05. That lead out looks good. This lead in does not. We're going to make that straight down at 6 o'clock. Hit check. Plunge parameters, make sure they're still okay. They carried over. That's good. Some of these carry over from op to op, some don't. So you're always better off checking and making sure. All right, so there's our finish pass, and you can see now they line up perfectly. So that is how I would generally program it. Okay, next thing we're going to do is we're going to drill and tap this. So let's go ahead and hit drill. Again, like we did on the tutorial, I'm just going to assume that we're using a carbide split point drill. If you are making something on the lathe, you're actually going to produce this, then unless you have a split point or carbide drill, you should be spot drilling it. So just because I'm not using a spot drill for this example does not mean you do not have to use one in the CNCs, does not mean that you do not have to use one when using Mastercam. You should be using it if you're producing parts and you don't have one of those 2 drills. Okay, so let's go ahead and go to our lathe drills. There's so many lathe drills here, I'm always trying to figure out which one's which. Yeah, that's it, lathe drills. Okay, I need a number 7. Oh, actually, no, we have a 3/8 24. Okay, so we need to calculate that. So let's go ahead and hit CAL, calculator, and let's bring that up. So we know our tap drill formula is diameter minus pitch. So if we take 1 divided by 24, we get 0.0416. All right, so if we take 0.375 minus 0.0416 equals, we get 0.3334. All right, so what drill do we have that's close to 0.3334? Just looking at my diameters here. There's 332. That letter Q drill looks pretty good, so I think we're going to take that letter Q. And I'm going to hit check. All right, so we're going to use our tap drill here. Our max spindle speed, we have constant surface speed off for drills. It looks like 805 is what they calculate. That looks pretty good to me. Inches per revolution, I mean, you can leave it in inches per minute. It doesn't really matter as long as you have the correct number in here. Since we work in inches per revolution, I'm going to say 0.003 inches per revolution. For this drill, you could probably make that 2 to 3 is probably the most you want to go here. I want to drill that diameter. Remember, I'm using a split point drill too, or a carbide drill in this situation. Depth, okay, looks like we have a 0.75 depth for the tapped hole. I'm actually going to drill this deeper because it's just telling me the tapped hole depth, and it looks like, by the looks of my print, that the drilled hole goes a little bit deeper. So I'm just going to say, I'm going to drill this 1.0 deep. And I'm going to leave that in absolute. Clearance is absolute. Retract is absolute. I am going to peck this because it's 1 inch. I probably could get away without pecking it, but I'm just going to, actually, you know what? Yeah, I'm going to leave the peck. So we're going to peck it, and we're going to use, let's see, we'll do it in 4 pecks. So let's make it 0.3. I go a little bit over, like obviously 1/4 inch would be 1 divided by 4 would be 0.25. I go a little bit over just to make sure that it's going to be all right. Plus, I'm also going to tip comp this as well. So let's see, that's what we want. I'm going to add that. Oops. Negative 1.0. And tip comp is going to be negative 0.009. Because I had a positive in here, it actually added a negative and reduced that number. There we go. So now it produces the correct number. All right, so that's good. And that's why I add that extra in there. So 0.3, obviously if it was 1.2, that would be divided by 4, that would be 0.3. So that'll be plenty to get us there in 4 pecks. That peck is deep enough to get us there. All right, so I'm going to hit check. All right, there is our drilled hole. Next, we are going to tap it. And we're going to have to go to a different library. And we're going to go to L taps. Oops, I just saw it. There it is. Okay, and we need a 3. Whoa, went a little far there. 3/8, 24 right-handed tap. Okay. Let's reduce this to about 500. Okay, automatically puts our, in this case, it is our pitch and our lead. If you're using a multi-lead tap, then this would obviously be different because you would be following the lead of the tap and not the pitch. In this case, the pitch and the lead are the same because it's a single lead tap. So that is our pitch, and our spindle speed's 500. That looks good. Here we are going to go to negative 0.75. And since I have extra at the bottom of my hole, I'm just going to go to that negative 0.75. Again, I'm probably going to either be using a form tap for this. I didn't calculate the tap drill for a form tap, but if I were actually making this part, I would either use a form tap or I would use some sort of bottoming tap. I would use a bottoming tap. I would probably use a spiral flute tap so that it pulled the chips out because it's a blind hole. And I would put this to exactly 0.75, which means it's not going to go quite deep enough. And then I would feather that in by changing the number in my program little by little until I got it to where I needed it. Generally, if a tap is called out, it's not exact to that depth. Usually it's at minimum of that depth. So you have to go at least 0.75. They obviously don't want you to go a 1/4 inch deeper or anything, but you want to go at least 0.75. If you're a little bit deeper, that's not usually an issue. Okay, we're not going to peck this. We are just going to, okay, all right, hit check. And there we go. So we have our tap, comes in and taps it. All right, next thing we need to do is we are going to just bore out to this little bit here. And as I did in the last, in the tutorial, I'm just going to trim this line. And I could have started by doing this, but I usually like to make it go a little bit lower, and to be honest with you, I just didn't really think about it when I drew the profile. So I just edited that just so it cuts. It still does a little Z face on here, but it doesn't need to come the whole way to center, obviously, because I already have all this material removed. All right, so let's go ahead and run a rough on this. Check. And obviously we are not going to be using those tools, and we can't do a tap, that's for sure. So let's go to lathe inch somewhere. Oh, there it was. I was just over it. There we go. Open. All right. Once again, I think we can actually probably step up to our 1/4 inch bar. We'll see. If we can't, we'll reduce it. There you go, our 3000, that's good. Our spindle speed, we'll probably run this around 500. Plunge feed rate's 5. Feed rate, we're going to reduce this to 0.006 just because we're using such a small bar. And of course, our depth of cut, we're going to reduce that to 0.025. Minimum depth of cut, we can make that 0.005 with a small bar. We're going to leave 0.005 on and 0.002. Everything there looks pretty good. I'm going to turn on my plunge parameters and leave computer on again. I'm going to change that all at the end. That lead in looks good. My lead out looks good as well. I do not need to extend this contour. And we're going to use remaining stock and hit check. Now, the reason I didn't extend that contour, as you can see, it's already extended past where we have our tapped hole. So that's fine. And it looks like our 1/4 inch bar worked just fine. So let's go ahead and run a finish on that. And just hit last, check. Everything there. I'm going to run this 500, 0.005. Finish. 1 pass is fine. 0 is being left. Computer. Lead in, lead outs are going to be okay. Your plunge is still fine. And I think everything looks good there. Okay. And I'm just going to zoom in. I'm just checking. See, everything lines up here. Of course, I can't get this square because of the tool nose radius, but that should be fine. If this did call out, if you were making a part where it needed to be square in there, obviously you would have to get an insert with a smaller nose radius and put it in there. That is the reason why I use control when I post code. So even though I've left it on computer right now, when I post code, I put it on control, and that is because I can change these inserts, and I don't have to go back and repost code to Mastercam. I can do it right at the control, right at the machine, and I'm away. I'm going. You know, if you wanted a really tight corner, now you might only use a 4 thousandths or an 8 thousandths tool nose radius, and you can do that just by putting it in your machine if you select control for your wear, or for your cutter compensation. So that's why I do that. All right, so we got these all finished. The next thing I might do, and actually, now that I think about it, I may have even waited till after I drilled and tapped to do this. The good thing about that is I can always fix that mistake. All I need to do is take my two lathe finishes, which are this one and this one. Also, naming these is never a bad idea. Rough, 0.3, radius, whoopsie, and then go here. I'll call this one finish 0.3. And the reason that that's nice to do sometimes, if you have a lot of operations, a lot of times when I work on 5-axis, it'll put it out here, by the way. When I work on 5-axis, I have sometimes 100 operations. So it's really nice to name them as you're going, because if you don't name them, you have no idea what anything is, and you have to kind of click on it and toggle the tool paths on and off. So it makes it a lot easier if you name them. So I'm going to drag this down to after that and drag this one down till after that one. Okay. Oops. What happened there? I think I dragged the wrong finish. I did drag the wrong finish down. Let's put that back up here where it belongs. Okay. Did I just drag the wrong one up again? I did. So this can be frustrating sometimes. Lathe finish. Wait a second. No, this one here belongs there. Never mind. I think I got it kind of right here. Yep, that's right. So that's the one way you can check, is to see your geometry. And then what you want to make sure is that when you're dragging these, that you don't, you can see I just moved it by accident there, that you only have the one that you want to drag checked. So let's drag that down again. Put it after there. Okay. Now I'm going to drag this one down and put it after that one. All right, so now that looks good. All right, yeah, that was just a little bit of an annoyance right there. Okay. So now if we regenerate that, so it does this last now. And the reason I did that was just because you probably want as much rigidity as you can get out here working on the end. You know, I might even drill and tap it first before I even rough this thing. So I might face it, drill, tap, and then do this bore before I even do the outside. Just so that I have the rigidity out here. And I think this part would probably be okay. I probably wouldn't have to worry about it too much. But if I was running it and I ran into an issue where I was getting a lot of chatter in this bore, I would try switching that around. I try doing this first and then roughing and finishing the outside. The problem is, you know, you may get a little bit of chatter out here because you've now hollowed this out. You know, it's one of them things where you have to figure out where, you know, where you want to, or how you're going to do it, just based off trial and error sometimes. But, you know, you can use common sense to figure out what's going to be more rigid. Okay, so last thing we need to do is do these grooves. So let's go ahead and do a groove. And again, I like to do different grooves so I can control them. So I'm just going to hit chain, and of course here, check. And I'm going to use the right-handed groove. Groove shape is okay. Use a stock as outer boundary. Bidirectional, so this is just talking about which ways it's going. Stock clearance is good. Step over 75%, that's fine. Remember, you don't want that to be too small, your tool might deflect. We're going to leave 5 thousandths on all sides so that we can come in and do a finish. You can see the finish here. Just comes in, goes across, comes in, goes across, meets in the middle. And in my compensation, of course, I would eventually change this to a wear or a control. So I'm going to hit enter. There's our groove. Let's go ahead and do that again for this one. Oops, reverse that. Hit check. So I know I didn't really change any parameters in here. So I'm going to hit check, and that looks good as well. Okay, last thing we need to do is cut this thing off. Select the back side of my part. There we go. This one, cut off from stock. I'm going to retract to stock. We're going to put a little chamfer on the back because we always should do that anytime we're making a part. 0.015, check. I'm going to make a clearance cut, and the Z should be 0 for that. From stock, hit check. And just leave that on for now. And there we go. All right, so let's see what we end up with there. Now, notice my part disappeared. So I know that something is wrong there. I will take points off for this, because if you don't have this on, then you're not really looking and seeing what happened. So I like to keep both pieces, or at least keep the separated piece. Keeping the piece in the active chalk doesn't show you anything. So I don't even know why that's really much of an option. I guess some people like to see what disappears, but I don't know. I don't get it. Anyway, all right, so there you can see my piece is still there. So let's go ahead and simulate that. Okay, so I'm looking all around to make sure my lines are visible. That tells me everything cut to the size that it's supposed to cut to. That looks good. Everything here looks great. See my chamfers on the back side, so that looks great. Yeah, that's it. That is a finished part. Now, of course, if I was actually making this part, I would definitely add chamfers to all edges that I could. I might even add a small radius right here, just so that this rounds it over just a hair. Even if it was like a 5,000th radius. That way I don't need to deburr it when it comes off the machine. Chamfers here. I would probably add a chamfer right here, and maybe even right here. So, if you're actually running the part, it's going to be a little bit different from these tutorials. You're going to take a little bit more time and make the part more complete. But at any rate, that is all I have for you for this lesson. So if you have any questions, of course, as always, you can see me in my office hours or during class.